Hello everyone. Before starting the lesson, try this warm-up. List the factors of 12, list the factors of 15. What is the greatest common factor of 12 and 15? Expand and simplify. This is what we were doing in the last lesson. And then what was the question? So what goes here so that when we expand and simplify, we get this as the answer? Pause the video, try all the warm-up questions, and then check back in. When we talk about factors, we are talking about numbers that you can divide this by. For example, you can divide 12 by 1, you can divide it by 2, by 3, 4, 6, or by itself, 12. Another way you can think of this is 1 times 12, or 2 times 6, or 3 times 4. Those are all the possible numbers that go into 12. Factors of 15 are, well, 1 times 15, or 3 times 5, so 1, 3, 5, and 15 are the factors of 15. The greatest common factor of 12 and 15, well, which common factors do they have? 1 and 3, and that's it. 3 is the greatest of those common factors, so it's the greatest common factor. When we're asked to expand and simplify, remember we're turning this into standard form. That means we're doing this, expand and simplify. X squared minus 3x minus 10 is the answer. And here, we'll work backwards. 2x got multiplied by what to get 26x squared? 3 got multiplied by what to get 39x? Well, it must have been 13x because 13x times 2x would be 26x squared, and 13x times 3 would be 39x. Now we're going to use this idea in a minute once we start the lesson. In the previous lesson, we looked at how to change from factored or vertex forms into standard form. In this lesson, we're going to start looking at how to change from standard form to factored form. And we're going to start with the basics of factoring. Today, in this lesson, we're just looking at common factoring. So we're going to be able to factor expressions with the greatest common factor. That's what we're going to look at in this lesson. And before we start getting into examples, let's just remember the words expanding and factoring. They're kind of opposite of each other. If I took this expression and I expanded it, I would be doing that distributive property 2 times x and 2 times 4. I would end up with 2x plus 8 as my answer. Now, if I started with the standard form and I wanted to turn it into the factored form, I would be going through that process backwards by factoring. So I want you to notice some patterns before we get too far into this. Up top, I have 12 plus 15. Now, I hope it makes sense to you that I can write 12 and 15 in factored form. Remember, in the warm-up, I listed all the factors of 12 and all the factors of 15, and the greatest common factor was 3. So I'm going to write 12 as a product of the factors 3 and 4, because 3 times 4 is 12. And I'm going to write 15 as a product of its factors 3 and 5, because 3 times 5 is 15. Now, because both of these terms have 3 as the greatest common factor, I can actually write my whole statement like this. 3 times 4 plus 3 times 5 is the same as 3 times 4 plus 5. I'm basically going through that distributive property backwards, because factoring is the opposite of expanding. Now, look at this. I have 12x squared plus 15x. What's the greatest common factor? 3x. I just have x's in there now, but it's the same process. 12x squared is 3x times 4x. 15x is 3x times 5. And I can rewrite that in a more simplified way, 3x times 4x plus 5. So I'm hoping that you can see this pattern where we're finding the greatest common factor of our terms, regardless of whether they have x's or not, and we're rewriting the whole expression as a product of factors. The first factor is the greatest common factor, And in the brackets is the other factor, and it's made up of what do you have to multiply the greatest common factor by to get the original statement above. So I'm going to show you that with this example. I'm going to factor this expression 10x plus 15. Well, if I look at 10x and I look at 15 and I think about what are the factors of those terms and what is the greatest common factor, the number 5 is what I come up with. 5 is the greatest common factor of 10x and 15. So that's one factor. What's the other factor? What goes in here? Well, it's whatever you multiply 5 by to get 10x plus 15. Well, 5 times 2x gets me 10x, and 5 times 3 gets me 15. So when I write 10x plus 15 in factored form, I write the greatest common factor, which is 5, multiplied by 2x plus 3. So I turn standard form into factored form by common factoring. Now you try. Pause the video and factor each of these expressions. Remember to find the greatest common factor and pay attention to plus or minus signs. So pause the video and try this. So here's what we get. 3x plus 15, the greatest common factor is 3. I have to multiply that by x plus 5. For the next one, the greatest common factor is 3. I multiply that by x minus 5. Now, if you had trouble, it was probably with these last two, and it's because of that minus sign in front. If minus 3 is the greatest common factor, I have to multiply it by x minus 5, because negative 3 times positive x is minus 3x, and negative 3 times minus 5 is plus 15. Likewise here, negative 3 times x is negative 3x, and negative 3 times positive 5 is negative 15. So pay attention to your plus and minus signs as you go through the process of common factoring. So now I'm going to start with a different expression. This one is a trinomial, 3 terms. I'm going to look at each term and figure out what is the greatest common factor of each term. Well, they're all even numbers, so I know that they're all divisible by 2. 2 is a factor that is common to each, but is it the greatest common factor? Take some time to think, and it is. The factors of 4 are 1, 2, and 4, but 4 is not a factor of 6. So the greatest common factor of 4, 6, and 8 is 2. So I know my greatest common factor is 2. What do I have to multiply 2 by to get 8x squared minus 6x minus 4? Think of it one term at a time. 2 times 4x squared is 8x squared. 2 times minus 3x is minus 6x, and 2 times minus 2 is minus 4. You're basically just working backwards, remember? So I've done the common factoring, and this is what I get. So follow the same process and try factoring these by finding the greatest common factor first. Pause the video and try this. Here's what I got. 10, 20, and 15 have the greatest common factor of 5. Negative 2, negative 6, and positive 4 have the greatest common factor of negative 2. Now, the reason I put a negative 2 as the greatest common factor is that I don't like having negative x squared in the brackets. That will make more sense once we do the next lesson, but for now, just get in the habit of not having a negative x squared in your brackets. This one here might have given you trouble. Notice that each term has x, which means x is part of the greatest common factor. So it's just like the question above it, except that each term has an x as well, so 5x is the greatest common factor. If what we've done so far is confusing you or you're not sure about some of it, you should pause the video and ask for help before you move on to the next part of the lesson. I'm going to change things a little bit here. We're going to do what's called factor by grouping. So here I have an expression, 9x squared plus 15x plus 3x plus 5, and I'm going to factor by grouping. Now this particular skill, factoring by grouping, is going to come into play a little bit later in the next few lessons, but I'm going to introduce it now so that you have a solid footing when you see it later. I'm going to start by grouping the first two terms and grouping the last two terms. Now, this isn't really any real math notation here. I'm just visually showing you that I'm grouping these. So this is more of something you would just do in your mind's eye. You don't draw brackets around anything. I'm just going to think of the first two terms as a group and the last two terms as its own group. Now, if I look at the first group, 9x squared plus 15x, and I find the greatest common factor, well, the greatest common factor is 3x. And what do I multiply it by? 3x plus 5. Because 3x times 3x is 9x squared, and 3x times 5 is 15x. Okay, so I do the common factoring for the first group. Now do the same thing again. Do common factoring for the last group. Well, 3 and 5, the only common factor they have is 1. So 1 is the greatest common factor, and I'm left with 3x plus 5. Because 1 times 3x is 3x, and 1 times 5 is 5. Now I want you to notice something here. These two terms both have 3x plus 5 as a factor. So 3x plus 5 is the common factor of both terms. So if 3x plus 5 is the common factor, what do I have to multiply it by? Well, 3x plus 1. So factor by grouping, you group the first two terms, common factor. You group the last two terms, common factor. And then, at this point, if you're doing it right, you'll notice that the greatest common factor is the same thing in brackets in both terms. You write that here, and what do you multiply it by? Well, whatever's here and whatever's there. They go as the other factor. Okay, so factor by grouping, this is how you do it. Now you try it for these, factor by grouping. Pause the video and try factoring these like I did on the previous slide. So if you follow the same process, you'll find the greatest common factor of these first two terms is x. The greatest common factor of the last two terms is 2. 3x minus 2 is the greatest common factor in the next line. And the other factor would be x plus 2. In here, do the same process, and we end up with this. If that's giving you any trouble, you should pause the video and let me know so I can help before you move on. Now this last thing is just something I want to show you. You might run into some practice problems that are similar to this, so I want to show you how to do it. What is the length of the triangle's base? So the base is the length of this line right here. We know the height of the triangle is 3x, and we know the area is 12x squared plus 48x. So in order to determine what the base is, we need to know what the formula for the area of a triangle is. And you might recall, to find the area of a triangle, you multiply base times height and then divide by 2. So if I plug in what I know, well, the area is 12x squared plus 48x, so area gets replaced with 12x squared plus 48x. Base, I don't know what it is, leave it as a b. Height is 3x, so replace height with 3x and divide by 2. So now I've updated my equation, and I need to solve for b. So if I multiply both sides by 2, I will eliminate the fraction on the right-hand side, and I'll end up with this. 2 times 12x squared is 24x squared. 2 times 48x is 96x. b times 3x times 2 divided by 2 is just b times 3x. My goal is to isolate b. I need to solve the base of the triangle, so I need to divide by 3x. So if I divide by 3x, I end up with just b on the right-hand side, and then 24x squared divided by 3x is 8x, and 96x divided by 3x is 32. All right, so the base of the triangle is 8x plus 32. And just for fun, let's factor that to make it look a little nicer. 8 is the greatest common factor of 8 and 32. We're left with x plus 4. So the base is 8 times x plus 4. So just remember what the goal is. The goal is to be able to change one form of a quadratic function into another. Part of that is factoring, and this lesson covered common factoring, and that's the simplest type of factoring. Factoring will get harder as we go, but for now, try these practice problems in the textbook and let me know how I can help.